Hi, I am Jinky Albarico and welcome to the magical world of number theory analysis. Today, I will be giving you your first dose of your daily math medicine. But first, I want to awaken your minds and straighten your spines by having a math game. I have here math riddles and I want you to try to guess the answers. Are you ready? So our first riddle, I am an 11-letter word. My first 3 letters is something that you can lay or sleep on. If spelled backwards, you can contain me in the middle. Who am I? What is the answer? Okay, very good. You have mathematics. Our second riddle, we have I am a 7-letter word. My first 4 letters form the Greek word for God. Take away my fourth and last letter, and I'll surely be there for you. Who am I? What is the answer? Yes, you have theorem. Third riddle, I am a 5-letter word. If you take away my second and fourth letter, I'll become your aim. Mr. Theory definitely needs me. Who am I? What is the answer? You have axiom. Our fourth riddle, I am a 5-letter word and it's obvious, you see. If you take away my first letter, I'll transform into a girl. Who am I? What is the answer? You have lemma. The fifth and last riddle, I am an 11-letter word. Just like F11 Pro, J7 Pro, and P30 Pro, I have a pro. Just look at me and you'll see my position. Who am I? What is the word? Yes, you have proposition. Very good. Okay, that's the end of our math game. Again, what is the first word? Yes, you have mathematics. Now, one of the many branches of mathematics is number theory. Now, what number theory does is that it takes all the types of numbers that we know, may it be even, prime, odd, and others. It takes all these types of numbers, asks questions about the relationship of the said numbers, and allows us to use formal mathematical reasoning to answer the said questions. But before indulging into the challenging topics of number theory, it is essential for us to know its basic terms. What are these basic terms? You have axioms, theorems, lemmas, and propositions. Let's start with axiom. Now, an axiom is a statement that is assumed to be true without proof. Why? Because axioms are statements which are self-evident and can be accepted without proof. Axioms are considered to be the building blocks from which all theorems are proved. In other words, axioms are like rules which set the boundaries or limits to which a theorem must be formulated. To illustrate this, I have here sample axioms taken from Euclid's Book of Elements. Okay, we have axiom 1. Things which are equal to the same thing are equal to one another. So, assigning letters to each circle, if A is equal to C and B is equal to C, then A is equal to B. Axiom 2, if equals are added to equals, the wholes are equals. So, assigning values to the triangles, we have 1 plus 2 is equal to 3, 1 plus 2 is equal to 3, and 3 is equal to 3. Axiom 3, if equals are subtracted from equals, then the remainders are equals. So we have 3 as the whole. So 3 minus 1 equals 2. Then 3 minus 1 is equal to 2. And 2 is equal to 2. Axiom 4, things which coincide to one another must be equal to one another. Therefore, the yellow square and the red square are equal. And now the last axiom, axiom 5, the whole is greater than its part. So if we will take one part of this whole 4, so we have 4 is greater than its part, which is 1. As illustrated by the 5 axioms of Euclid, we can really say that axioms are self-evident. Next will be theorems. Now, theorems are logical consequence of axioms. It is a mathematical statement that is proved using rigorous mathematical reasoning. So, theorems, they are considered as the major results of proving. Now, theory and theorems are not the same things. Theory is a statement inferred from a set of observations or facts but is never proven to be true. Whereas, a theorem is a statement which has been proven from known propositions, lemmas, and axioms. If it is a theorem, then it is forever a theorem. Okay, we have the following examples. First is the fundamental theorem of arithmetic, which states that every integer greater than 1 either is a prime number itself or can be represented as a product of prime numbers, and that, moreover, this representation is unique up to the order of the factors. Now, the fundamental theorem of arithmetic is based on Peano's axioms. Next example, we have the Chinese remainder theorem, which states that if one knows the remainders of the Euclidean division of an integer n by several integers, then one can determine uniquely the remainder of the division of n by the product of these integers under the condition that the divisors are pairwise co-prime. Now, the Chinese remainder theorem is based on the well-ordering principle and the definitions of the GCD and LCM and others. Okay, next we have proposition. Now, a proposition is a statement which is offered up for investigation as to its truth or falsehood. In other words, it is a statement which has truth value. It is either true or false. Now, proposition is an ordinary true mathematical statement, meaning it is not as important or difficult as a theorem. So, we have the following examples. First, 17 plus 25 equals 42. Is it true or false? That is true. Second, 7 is greater than 12. Is it true or false? It is false. And the last one, we have number 3. 8 is less than 20. Is it true or false? You have true. Okay, next we have lemma. Lemma is a minor result whose sole purpose is to help in proving a theorem. So, it is another word for theorem but not as interesting as a theorem. Rather, it is seen more as a stepping stone than a theorem itself. Okay, we have the following examples. First, the Euclid's lemma, which states that if a prime number p divides the product AB of two integers a and b, then p must divide at least one of those integers a and b. Now, Euclid's lemma is the key to proving the fundamental theorem of arithmetic. Second theorem, we have the Gauss lemma, which states that for any odd prime number p, let a be an integer that is co-prime to p. Now, the Gauss lemma is used to prove various theorems in quadratic reciprocity. So, how are they related? What is the relationship between the four terms, the theorem, the axiom, the lemma, and the proposition? Remember that a theorem is a statement which is proven by valid logical inference within a mathematical theory from the fundamental axioms of that theory. Now, upon proving those complex theorems, we often break it down into steps or smaller theorems for which we combine to prove it. Now, those smaller theorems or steps are known as lemmas and propositions. That ends my discussion on the basic terminologies of number theory. I hope that you have learned something from me. Again, my name is Jinky Albarico. Goodbye and God bless.